Dear learners, welcome to ARPIT in Library and Information Sciences at IIT Delhi. I am Niladri Chatterjee, Professor of Department of Mathematics at IIT Delhi. Also, I am the Chair Professor of Artificial Intelligence in my institute. In my talk, I shall explain the role of artificial intelligence in developing information systems. In particular, my focus will be in acquisition of knowledge and its representation in an information system. The talk will be in two parts. In part 1, I shall build the foundation, and in part 2, I shall explain some technical details pertaining to knowledge representation. In the last less than one decade, two terms have gained huge attention in computer science community, and these are artificial intelligence and machine learning, and the another one is data analytics. These two terms are apparently different from each other, but they are very nicely intertwined, and with time, as the amount of electronic data is growing exponentially, we see that in many different applications of artificial intelligence and machine learning, we use that data to build our AI based systems, which can be any information system in general or can be a library systems in particular. So, in this talk, I shall try to explain to you how is data being so relevant for our modern day design of different information systems. Now, natural question will be how and why. How data is being used for AI based systems and why it is so useful for today's world. To understand this, we have to go back to the history of artificial intelligence. A common question that people often ask me that artificial intelligence is a new thing, so why it became so popular so quickly? In fact, that is a wrong notion. Artificial intelligence is very old concept of at least 60 years old. So, to understand that, let me first define what is AI. AI, in a very simple term, is an area of computer science that aims at reducing the gap between man and machine, or in other words, it aims at creating machines that behaves or reacts like a human. Hence, machines which are empowered with different human abilities, both mental and physical, that knowledge has to be imparted, or our machines have to be empowered with those abilities, and that is precisely the goal of artificial intelligence, and it led to various directions of research. For example, how to make a computer understand human language. Research in this direction is called natural language processing. In a similar way, how to make a computer see and react, that leads to computer vision. But if we analyze these systems, we see that all AI based systems require certain amount of expert knowledge to be coded into that system for ready use. For example, you cannot think of a medical system without the knowledge of diseases, their symptoms, their causes, the medicines that are appropriate for them, the virus that cause that disease, etc. In a similar way, if you are designing a legal system, you need to incorporate the knowledge of the laws, the bylaws, different clauses, different past judgments, etc. Similarly, in a library system, you may need to store the knowledge about the books, their publishers, their authors, different journals, their subjects. All this knowledge need to be incorporated into the system so that it can function up to their expectations. And this thinking started, as I said, more than 60 years back. Say for example, the term artificial intelligence was coined by John McCarthy in the year 1956. Around the year 1959, Simon, Shaw and Newell proposed the concept of general problem solver. They thought that there can be machines which can behave like a human and solve all our problems. Therefore, the research was focused on collecting and storing all human knowledge pertaining to different domains and storing that in a machine. Thus, two important aspects of artificial intelligence or AI based systems are knowledge acquisition and knowledge representation. That means, how do you acquire the knowledge, the domain knowledge or functional knowledge of the system, and how do you represent them inside the system for future use. That is the main focus of my talk. Now, in early AI systems, early means I am talking about 1960s or early 1970s, the AI systems that were built, the knowledge was acquired from domain experts. But elicitation of knowledge from experts have many difficulties. For example, expert may not be available. If you look at say today's problems, we do not have experts who can tell how to predict whether there is going to be an accident or not in some corner of the road, or how do you control the spread of dengue, where one should invest the money so that one can make profit, or in other words what I have called the share price prediction. There is no expert who can guarantee success in these domains. In a similar way, there can be a domain where two experts have two different opinions. So, legal systems, for example, in any case there are two lawyers from two sides and their interpretation of the case in hand are completely opposite to each other. Similarly, at times experts may not be able to articulate their knowledge, because often experts behave on their intuition or from their experience, which they may not be able to articulate in such a way that it can be coded inside a machine. And more interestingly, expert may not even exist. There may be many domains where nobody knows who is the right expert whom to approach for acquiring the relevant knowledge. Hence, the question is where from the knowledge is required for developing a modern AI system may be acquired, or in other words, how do you glean the knowledge so that you can make your system effective and efficient. Now, the solution comes from a novel perspective, that is data. As I said at the beginning, now lot of data is available in electronic form. Can we use the data in such a way that we can acquire the relevant knowledge for a particular types of problem? In this respect, I show you this diagram which is called DIKW pyramid: data, information, knowledge and wisdom. So, what is data? Data is numeric or alphanumeric without any meaning. Say for example, I say 300, nobody knows what it means. It may mean the number of books that I have in this shelf, it may mean the number of readers who are currently studying inside the library, nobody knows, it is just a data. So, it does not have any semantics. At the next higher level, what we see is called information. When we attach the meaning to the data, then it becomes an information. When we have the information sufficiently gathered, then that gives us the knowledge about the domain, and that tells us what to do and how to do. That is, we gain a procedural knowledge from this information, and when we have enough knowledge we become wise, or in other words, from knowledge we gain the wisdom and we can criticize and we can ask questions why something is being done, or we can become judgmental whether it is good or bad. That can be gathered from those knowledge when we have the wisdom. So, let me give a very simple example to illustrate that. Suppose I am talking about a library where we have a large number of books and each book has an accession number, let me call it xi, and let yi be the registration number of the user who borrowed that book. So, all the borrowing records of the library I am storing in the form of pair numbers xy and yi for the ith entity, and the raw file is my data. Once I have so much of data, I can do a simple statistical processing to see which book has been borrowed how many times. So, we are trying to generate some information out of the data, and this I can store in the form of a table. Again it is a paired entity xi ni, where xi is the book's number and ni is the number of times that book has been borrowed. Now, once we have the information over a large number of days, then we gain knowledge. The knowledge is that which book is very popular among the users, and therefore, it helps the librarian to decide which books are to be purchased in the next lot. And from the above knowledge, we can become wise in that domain, or in other words, it can give us the desired wisdom about how to plan regarding the purchase and writing of books for future, what are the subjects that are coming to be more pertinent in coming years, what are the subjects that are losing their steam with time. All this knowledge when we gather, we become wise in that domain. So, I believe this simple example tells you how from data we can generate information, and from there the knowledge that we need to design that system. So, in computer science jargon we write that data leads to information, information leads to knowledge, and knowledge leads to wisdom. Now, lot of data is available in the electric form or electronic form. Say for example, in the social media, if you are talking about libraries, the publisher's catalog, there are advertisements for books, journals, etc. There are reports from different libraries, there are reviews available for different books, there are pamphlets that the institutes are providing about the any modification in any upgradation of their courses. So, all those data is now available to us in an electronic form, and one can decide to design information system based on that data. The question is how to extract the knowledge out of it, so that we can incorporate it in our system. So, it will not be completely out of the context that this is called machine learning. So, on one hand artificial intelligence which needs knowledge, we get the knowledge earlier from experts, but nowadays we get it from the data if I can process it meaningfully, and that is called machine learning in modern day jargon, because here we are making the system learn from the data. So, I hope I could make it clear how data and AI are intertwined so nicely in modern times. Therefore, the question comes, how do I manage that knowledge? So, in first step in this direction is searching for desired information in data, because that data that we are looking for, that is not open to us, it is hidden somewhere in the data. We need to churn it out of the data. Say for example, there are social media where friends are sharing their liking and disliking of a books, but that is not the only thing they are sharing. They are sharing many other details. Out of that, we need to take out the relevant part that is needed for building our system. So, typical search is over the web pages scattered all over the internet. In modern days, the internet is the greatest source of data, and the relevant information is scattered all over. We need to identify from there how to extract the relevant knowledge. Now, the search procedure that we generally use, that is keyword based search, and that does not give us desired result all the time. So, I give you a simple example here. I was searching through Google search engine who teaches AI in IIT Delhi. The top few results that it returned, if you look at it, I have given here the top 3, none of them has any relevance with respect to AI teaching in IIT Delhi, and of course, not who are the teachers of AI in IIT Delhi. So, I changed the query. I maintained the semantics of that one and I searched for AI teachers in Delhi IIT, and if you look at it, the results that it has generated has nothing to do with the query. So, such simple example tells us that just keyword based search is not right. Why the search engine has returned this? Because it tried to match the keywords AI, Delhi, IIT, etc., and based on certain ranking functions that they have used, they have popped up these to be the top 3 of the search results. So, the lesson is that we should organize the knowledge in a semantic way or in a semantic space, so that the search engine understands the query and it can identify the relevant pages from all over the internet. But that is not an easy thing. For example, I have given the first example, the bank is near my house. What is the meaning? If I do not say anything, everybody will think, okay, they have understood what I wanted to say, but there is a small twist there, because the word bank is a polysemous word. It has more than one meaning in English. It may be a river bank, it may be a financial bank, and therefore, when we say the bank is near my house, it actually does not give a clear sense of what I am going to say. Example number 2, the computer is printing data, it is fast, and another sentence is the computer is printing data, it is alphanumeric. Now, let us ask, what do I mean by it, the pronoun it, it. If you look at it, in the first sentence, when I say it, here it means the computer, because it is the computer which is fast. In the second sentence or second pair of sentences, when I say it, it is actually referring to the data, because it is the data which is alphanumeric. Now, from the construction of the sentences, it is not clear actually what the pronoun it means. In a similar way, let us look at the third example. Suppose I say the book is interesting, then I am giving some positive comment about the book. But if I say, do you think the book is interesting, it may be positive, but it may have a negative connotation, because I am doubting perhaps the quality of the book. Example number 4, consider the two sentences which look exactly alike. The first one is Deepika and Ranveer are married now. Anybody who is knowledgeable with the domain, they know that these two persons are now married to each other. On the other hand, if the second line is Virat and Ranveer are married now, then we are saying that these two gentlemen, Virat and Ranveer, are now married, they are no more bachelors, they have their spouses. So, the sentences have the same structure, but they have two different meanings. These above examples suggest that acquisition of knowledge is not so simple from text, and knowledge has to be therefore put in a conceptual space, and where just key based search will not work, and the search may spread over several documents, and there should be hyperlinks so that we can transfer our control from one document to another. Also, it should have a query answering capability, because in many cases we shall be asking questions, particularly about who is the author of a book, whether the book is available or not. I am talking in terms of libraries, and you can see that this system should be enabled to have the capability of answering such queries, and the information can be readily interpreted by the machine without human intervention. Otherwise, there is no point in developing an information system if human beings have to operate with it constantly. Therefore, obvious question is how to do it. So, we have to focus on semantics, so that the machines have the capability of interoperating with each other. Each semantic conflict needs to be resolved for this. Now, what is a semantic conflict? Just now I have explained with these 4 examples that the straightforward meaning that comes from the structure of the sentence or from the syntax of the sentence is not always the right thing. There is something deeper in it which has to be found out to understand that where is the semantic conflict. All of you may be aware of wordnets. Princeton University has English wordnet. In India, with respect to different Indian languages, there is a Hindi wordnet that is hosted in IIT Bombay. If you look at it, you will find that it enlists different synonyms, homonyms with respect to different nouns and verbs. So, that is often useful in resolving our semantic conflict. For structured information, we look for structures. Those who are related to computer science, you know that in a structure we incorporate different fields, and in each field there are certain information. So, that if two structural entities are matching in their structures, we can think that they may be similar. Say for example, a real number is only one number, but when you talk about complex numbers, we are talking about a pair of numbers. So, when there is a pair of number, we can interpret it as a complex number in a relevant domain, and in that case we should be able to map between structures. However, most often such one-to-one mapping will not be possible or will not be applicable also. Hence, discovering the semantics is very primary for such a domain, and one simple technique for this is called semantic annotation. For example, consider this from agriculture domain. This is available in certain books with respect to agriculture, particularly with respect to Indian agriculture. Now, for a computer, these are strings of characters. What is the meaning attached that computer cannot understand unless a human expert attach the meaning with different words of this text. This is what we call semantic annotation, and one can think of the following. Say we can see that here we have written, or an annotator has written, that Rabi is a crop type, spring is a season, November is a month, ground is a natural thing just like say rain or water and things like that. Similarly, crop is an agricultural thing. Like that, we have annotated different meaningful words of this text. Now, this annotation helps us in acquisition of knowledge. Of course, we cannot do it on our own unless we speak to the experts. That is why expert intervention is needed at the very beginning, but once the experts give their opinion, we can implement that and we can use that for extracting data automatically. For illustration from this previous small text, we can easily see that November and April are months of a year. November to April should be a sequence of months, and a sequence of months is to be called a season. In a similar way, one can see that all the physical things can be natural or agricultural. Say for example, crop is a thing of agriculture type, soil, water, etc. are natural things, and thus from such a small piece of text we can acquire so much of knowledge which are going to be useful if we want to design a system for agriculture in India. Now, the question is how to store this knowledge conceptually, what I was saying in a semantic space. There are many techniques for that one. For example, one is say graph based representation. The entire knowledge with respect to a particular domain can be put in the form of a graph, so that we can understand the relationship between different entities that are pertaining to that domain. And also another thing is that which is called a markup language, and we can use different tags for textual representation of the information given in a particular text. As I said at the beginning that in this talk I am going to give you the background. So, I hope that this small piece of lecture that I have given now will help you to understand how an AI based system can be designed for information processing with respect to any domain, and then how the knowledge can be acquired from different texts. The problem of knowledge representation is somewhat more technical. So, in this talk I did not use much of technicalities, and in my second talk I shall give you some knowledge about how this knowledge can be represented using a graph or using a markup language. Okay, friends, I stop here today. I give you my heartiest thanks for listening to this talk. I convey my thanks to the Central Library of IIT Delhi for organizing such a series of talks which will help us to understand what goes on inside building a library information system. Now, I have given my email here. For any queries or clarification of any doubt, you may please contact me, or you may contact on the discussion forum of ARPIT. That will be very useful, because more people will be able to access that and they will be able to understand anything that they might have found to be difficult. With that, I stop here today. Thank you very much again. Thanks.